A shopping mall in a local town wants to know whether customers would prefer complimentary gift wrapping or assistance carrying their purchases to the car during the busy holiday shopping season. It says classify each sampling method. So part A, survey those who ask the shopping mall info kiosk for a questionnaire. So since the people have asked for the questionnaire, that's going to be self-selected. And part B says survey every 30th household in the town. And so since it's every 30th, it's going to be systematic. Part C says survey all households on 6 randomly selected streets. So the key is that it's saying that you're going to survey all of the households on 6 randomly selected streets. So that's going to be your cluster sample. So you're looking for the word serving all of them, and then it's going to be a number that's randomly selected, and that will be your cluster. Part D, survey a random selection of those who happen to be eating in lunch in the shopping mall food court at 12:30 on a Saturday. So that's going to be your convenience sample. And then it says survey 5 randomly selected households who live in the south side of town, 5 randomly selected households who live in the north side of town, and then similarly who live in the west side, and then also on the east side. So since you're picking a set number that's randomly selected in each area, that's going to be stratified. For number 2, counselors at a school want to know if students think that there should be more assistance offered with college applications. So part A, it says the counselors use a randomly generated list of 45 students from a master list of all students. So I'm looking at the word randomly generated list. So that's going to be your simple random. Each student has an equally likely chance of being chosen. This method isn't likely to result in a biased sample because the students are chosen randomly. Part B, the counselors survey the first 40 students who logged into Naviance during the month of October. So that's going to be convenience because they're not choosing like every 10th person, it's just the first 40 people who logged in. And the reason why is the students are easily accessible. It says this method is likely to result in a biased sample because it does not include students who did not log into Naviance. There are 400 freshmen who attend a small private university. The student union wants to collect some information on the freshmen, so they randomly select 10 of those 400 freshmen to survey. So you can see that you have your different majors, and then it also states whether the student commutes or lives on campus. Part A, if the student union wants to know how many freshmen commute to the college, predict the number of freshmen who commute. So we'll look up here and we'll look at how many commute. Say that there's 3 out of, and there was a total of 10 freshmen who commute. And so that's equivalent to 0.3, or that would be 30%. So now that we found the percent of freshmen who commute to college, we could predict the total number of freshmen who commute. So we're going to take the total students, which is 400, and we're going to times by 0.3, and if you multiply those, you get 120. Part B, if the student union wants to know how many freshmen are working towards a Bachelor of Arts degree, predict the number of freshmen who are working towards that BA. The percent of freshmen who are working towards a BA degree. So we'll look up here for Bachelors of Arts, the BA degrees. There's 1, 2, 3, 4, 5, 6. So it'd be 6 out of the total 10, which is the same as 0.6, or 60%. And then if we actually predict the number of freshmen who are working towards the BA, we're going to take 400 and times by 0.6. If you multiply those, you get 240 students. For number 4, it says find the mean, median, and mode for the data set. If necessary, round your answer to 1 decimal. To find the mean, we're going to add up all the values, and then we're going to divide by the total number of values in the data set. So it's 202 divided by 8. It said to round your answer to 1 decimal, so our mean is going to be 25.3. Next, to find the median, we're going to put these values in order, so we'll go least to greatest. If it helps to cross out the values as you list them, that might be good just to make sure you didn't miss any. If we go from the outside in, we have 2 and 35, 18 and 32, 27 and 30, 28 and 30. So we're looking for a value right in between 28 and 30, which would be 29. So that's going to be our median. The mode is the value that shows up the most. So you can see the only value that shows up more than once is 30. So your mode is going to be 30. We're going to do the same thing for problem number 5. So to find the mean is the average. So we're going to add up the values. And then we'll divide by the number of values in the data set. So we're going to divide by 5. And then round our answer to 1 decimal. So when you round that, it's just going to be 8.0. Again, to find the median, we need to put our values in order. And we'll go from the outside in. And so this ends up being your median. And finally, the mode is whichever value shows up the most, and so we can see that that's 7.1. Number 6 says find the standard deviation for the data set, if necessary round to 1 decimal. So what we're going to do is we're going to put the values in a list, so we're going to press stat, and then we want to edit, so press enter. And if there's already numbers in this list, you can arrow up to the L1, highlight the L1. You can press clear and then enter, and it will clear out any numbers that are previously there. So let's go ahead and enter these values. So once you have all your values in the list, you're going to press stat again, and then we're going to arrow right to calc, and then we're going to do one variable stat. So enter, and then just keep pressing enter till it kicks out all of our values. And for standard deviation, we're going to use the lowercase sigma, this guy right here. It looks like a sideways B, and so our answer 1 decimal is going to be 15.5. So 15.5 is our standard deviation. For number 7, it says find the quartiles and inner quartile range IQR of the set of data without using a calculator. So no calculator, we're going to put these numbers in order. Alright, so once you have them in order, you can go from the outside in, and you can see that your median, your Q2 falls exactly in between 10 and 14. So you get 12. So that's going to be your median. And again, it's whatever value's in between those two. If it's harder for you to distinguish that, you can always add these and divide by 2, and that will give you your answer. Now to find your Q1 and Q3, what you do is you cover up this median, and with the values that are left, you count them in. So it would be, so you cover this up and you count in. So 10 and 2, then 9 and 3, and then the 8. That becomes your Q1. And we'll do the same thing on this side. Cover up the median, and you just look at the values that are to the right of it. So you have 14, 20, counted in, 15, 17, and then there's your Q3. And your IQR is Q3 minus Q1, so 16 minus 8, and you end up just getting 8 for your IQR. For number 8, to start off, to find your quartiles and IQR, you're going to, without a calculator, line them up. Okay, once you have them in order, you're going to count in from the outside. And here is our Q2, our median. And then you cover up the median, and then you go to the left and you count in. So 9, 3, 3, 4. So here's our Q1. It's going to be exactly in between 3 and 4. And we'll do the same on the other side, cover up the median, and then count in with the values that are to the right of it. And then our IQR is Q3 minus Q1. And you end up getting 9. For number 9, it says find the quartiles and IQR of the set of data using a calculator. So again, we're going to go to Stat, Edit, and then we'll go up to L1 and clear this list. And now we can enter our values. Once you have your values in your list, you're going to press Stat, Calc, Enter, Enter, Enter. And it kicks out all of our values for that data set, and then we'll go down and you can see that here's your Q1, the median, which is your Q2, and your Q3. And then your IQR is taking Q3 and subtracting Q1. Number 10 says to make a line plot for the data. So we're going to look at our smallest value, which is 5. And we're going to count up from there. So we'll go. So for your line plot, you're just putting x's above these values. So we'll give an x on the 14, then on the 5, keep going. Okay, so there's our line plot for this set of data. For number 11, it says identify the type of distribution for each line plot and find the mean and median. So first you can see the data values are going down to the right. So we're going to say that this is a skewed right. So number 11. The type of distribution is that it's skewed right. And again, you can look at this. It kind of looks like a slope. And if you had someone skiing, here's my little guy on skis, the person is skiing to the right. So it's kind of nice to think of that as skewed right or ski right. Next, it says find the mean and median. So for your mean, again, we have to add up all the values and then divide by the number of them. One way to do this is you can go in your calculator and just do 1 plus 1 plus 1 for every x in the one column, or you could just do 1 times the number of x's in that column. So if we count them, there's 1, 2, 3, 4, 5, 6, 7, 8. And then you would add to that the number of x's in the column that has a 2. So we'd say 2 times, and the number of x's is 1, 2, 3, 4, 5, plus the third one we have 3, plus for the 4 we have 3, plus, and then for the 5 we only have 1x. So that gives you your total. You have 44 total divided by, and then we'll need to count how many x's there are in total. So that would be 8 plus 5 is 13, plus 3 more is 16, plus 3 more is 19, plus 1 more is 20. So you have 20 values. And so you end up getting 2.2, and that will be the mean. And then your median, these x's are in order because, again, this represents 1, 1, 1, and so on. This represents 1, 5. So to find the median, we can just go from the outsides and knock off a value on each side. So you count off this one with one of these 4s, and so on. And then you move over to 1 and 3. And then this and this get canceled out. So if you'll notice, if you keep canceling out on either end, you end up in the column that has 2's. So your median is just the value 2. For number 12, it says, for the line plot, determine whether the mean is equal to, less than, or greater than the median. So first off, we want to identify which type of distribution this is, and it is skewed left, because again, if you make kind of a slope, the slope is going down to the left, so this is a skewed left. So number 12 is a skewed left. Anytime you have a skewed left problem, the mean is less than the median. So what's really nice is when it says skewed left, your mean is less than, so the L and the L always go together. If you have a skewed right, then the mean will be greater than the median. And the word greater has an R, so that is also helpful. 13 says make a histogram for the data without using a calculator. So what we're going to do first is we're going to determine the number of intervals. So to find the number of intervals, what we do is we take the square root of the number of data values. So 1, 2, there's 13 values. So we're going to go square root of 13, and the square root of 13 is approximately equal. It says 3.6, so we'll approximate that to 4. The next thing we need to do is find the interval length. To find our interval length, what we do is we take the greatest value. So we'll go through and find which value is the biggest. And it looks like it's 98. And we'll subtract the smallest value. And that looks to be 62. And then you divide that by the number of intervals, which we just got was 4. So we're going to go 98 minus 62, divide by 4. So you're getting 9. So each interval length needs to be 9. So here's our 4 intervals. We have 1, 2, 3, 4. And then each interval length needs to be 9. So we're going to start and go 62, and then we need 9 units. So this first interval is going to be 62 to 70, and that's a length of 9 units. Then you'll go 71 to 79. Next, we'll start at 80, and then we go to 88, because if you count out 80, 81, 82, 83, all the way to 88, that would be 9 values. And then finally, we're going 89 to 97. And then if you just double check over here, you can see that you still have the 98, so we'll just do one last one. What we're going to do is we're going to count how many values are falling in each category. So if we count how many values are between 62 and 70, we have 68, 62, and that's it. So what we'll do is we'll go up 2 units on the y-axis and draw a box that goes from 62 to 70 and goes up a height of 2. Then we'll keep going and look for all values that are between 71 and 79. So there's 3 different values that were in that interval, so we'll go up 3 with the box, and then we'll do the same for the rest of them. So we're going to keep counting how many values are falling in the interval, and then that's how high your boxes will go. And there's our histogram. For number 14, it says use a calculator to make a histogram for the set of data and identify the type of distribution. So first what we're going to do is we're going to find the number of intervals. So to do that, you take the square root of, and then you count how many values are in your data set. And you get 3.7, but that will round up to approximately 4. Then we're going to do the length of the interval. So what that is you take your largest value and you subtract your smallest value, and then you divide by the number of intervals that we just got, which was 4. And that ends up being 4 over 4, or just 1. So what I want to do is, in order to use the calculator for the histogram, we want to this time fix the window. So for your window, you have an x minimum, and your x minimum is going to be your smallest value. So our smallest value is 1. Our x max is our largest value in the data set, which was 5. And then our x scale is going to be the value we just got for the length of interval. So our length of interval is 1, so that's going to be your x scale. Go ahead and do stat, edit, and then type in all of our values. Okay, then we're going to go second y equals, and make sure our stat plot is on. So make sure, again, it says it's highlighted on the on. And then we're doing a histogram, so we're going to go over and make sure that this one right here, the third one over, is highlighted. So now that it is, press window, and let's make sure these have the right values. So our x min is 1, our x max is 5, and our x scale needs to be 1. And then go ahead and hit graph. And there's our histogram. Now if we want to draw this onto our paper, we can press trace. And this tells you, you look at the n equals, that tells you exactly how high the box is in each interval. So your first interval, it goes to a height of 2, then we're at a height of 5, then a height of 4, and finally a height of 2. So let's go ahead and draw that on our paper. And there's our histogram. For 15, it says create a box and whisker plot, or we call it a box plot, for the set of data without using a calculator. So the first thing we're going to do is put our values in order from least to greatest. We can now identify our Q1, Q2, and Q3s. So that's your Q2 or your median. And then you cover up the median to find your Q1. You look at the values to the left of it and count in. And then for your Q3, you do the same thing, cover up the median and then count in with the values that are to the right of it. Okay, next we're going to make a number line. And we're going to put the lowest value, which is 4, on the number line, and then we have to go all the way to 22. So I'm going to go by even, so I'll go 4, 6, and so on. Alright, and then what we're going to do is we're going to plot the Q2, which is 15, so that falls right in between 14 and 16. And then we'll plot the Q3, which is 17, so that's right in between 16 and 18. Q1 is 12. And then you create a box using those points. And then finally you put a dot at your lowest value and your highest value, and those create the whiskers on your box plot. Number 16 says using a calculator, create a box plot and use it to describe the data. So the first thing we're going to do is do stat, and then we're going to edit, and then go ahead and go up and clear any list values that may be there. And we're going to start entering our values for this data set. As soon as you have all your values in your list, go ahead and press second y equals and press enter. And then we're going to go down and select the type of graph we want, and we want the box plot, which is right here. Press enter. Next, we're going to change our window, so press window, and we're going to enter our min and max values. So you want to look at your data set and you want to identify what is your smallest value in the list. It looks like our smallest value is 27. Then we want to identify the max value, so in this list it looks like the max is going to be 42. So again, our min is 27, our max is 42. And then go ahead and hit graph, and here's our box plot. So I'm going to press trace, and it shows that the median is 38. And if we go left, you can see that Q1 is 37, and if we arrow right, you can see Q3 is 39. So let's go ahead and draw that on our paper. Okay, so you can see that the minimum value is 27, the maximum is occurring at 42, and then your Q1, Q2, Q3 are occurring at 37, 38, and 39. (17 through 19) say use the given histogram to find the probability that a data value will fall in the specified interval. So for number 17, our interval is 31 to 50. So if you look down here, you can see 31 to 40 and then 41 to 50. So it's going to be these two intervals. So 31 to 40, 41 to 50 gives us the total interval. And what we're going to do is we're going to look at every interval and see how many values are falling in each interval. So this first one, you have 1. This next interval, you have 4. And then keep going. So the specified interval would be the 31 through 50, so that's 6 and 12. So we're going to go 6 plus 12 over, and then we're going to add up all the values for the denominator. So our total is 51. So we end up getting 18 over 51, which actually reduces. If you ever want to try reducing down on your calculator, you can go 18 divided by 51. And then if you press math right here, press the math button, and then you use fraction, it'll kick out the decimal in fraction form. So 6 over 17. Okay, we're going to do the same thing for number 18. So in this first interval, you're going up a height of 1. The next interval goes up to 5, 3, 2, and then 1. And we want the interval from 60 to 99. So that's going to be here and here. So that's 2 plus 1 over a total of, add up all the values, you get 6, 7, 8, 9, 10, 11, 12. So you get 3 twelfths, which is the same as 1/4. Okay, for 19, in this first interval from 10 to 11, you have a height of 3, and then you have 2, then 1, and then 2. And we want from 10 all the way to 12. So you can see that would be 10 to 11, 11 to 12. So it's going to be these two. So we go 3 plus 2 over, and then we'll add everything up. And you end up getting a probability of 5/8. For number 20, it says, given the mean and standard deviation, find the interval for data that are 1 and 2 standard deviations from that mean. So we're going to start with finding the interval for data that are 1 standard deviations from the mean first. So 1 standard deviation. So what we're going to do is we're going to start with the mean, and we're going to subtract the standard deviation, and that will be less than x, which is less than, and then you take the mean and you add the standard deviation. So when you work this out, you get 9.9 is less than x, which is less than 14.1. So here's your interval. Then for 2 standard deviations, what you do is you take that mean and you subtract 2 times the standard deviation. Then you take the mean and you add 2 times the standard deviation. And I'm going to go ahead and enter that right into the calculator. So you end up getting 7.8 and 16.2. And there's your interval for 2 standard deviations. For 21, it says, given the set of values, find the interval for data that are within 1 standard deviation from the mean. So press Stat, Edit, clear out whatever's in the list, and we're going to enter all the values from our data set. Once we have all the values in, we're going to do Stat, arrow to the right for calc, press Enter, 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 Enter. And your mean is the x with the bar over it, so our mean is 15. And our standard deviation, we're looking at the lowercase sigma that looks like a sideways b, so it's going to be 3.4. And we'll set up the interval again. So we'll go mean minus the standard deviation, And then we'll go the mean plus the standard deviation. So you end up getting 11.6 is less than x, which is less than 18.4. And there's our interval.
Come on, that's just the way it is. Things will never be the same. That's just the